Dear all, welcome to today's session. In today's session, we are going to see about the introduction to reinforced concrete elements. So, if you see in today's class, we are going to see about the what you mean by RC structures or RC elements and learn the properties of concrete and reinforcement steel and understand the structural demands. So first of all, we need to know what is reinforced concrete. So reinforced concrete, it is a combination of concrete and steel. So here if you see in this picture, we have the steel here and we have the concrete here. This combination is called as reinforced concrete. Why we need to combine these two? Because we know that the concrete is strong in compression but it is weak in tension. And to overcome that, we are introducing steel into the concrete because steel is strong in both tension and compression. So by combining the concrete and steel together, we are creating a composite material which is called as reinforced concrete. So here if you see, this reinforced concrete is used for construction of buildings, bridges, tanks and foundations. So the components of RC structures. So the components generally concrete and reinforcement steel are the components of RC structures. So the concrete will carry the compressive force and the steel will carry the tensile force. So the load transfer between these two happens by bond between the concrete and steel. So here the common elements, because in buildings we have beam, slab, column, footings and staircase. So here in this picture if you see, this is nothing but the concrete and this is the reinforcement bars, because it has given all the bars which we are currently using in the which we have used in the field and currently using in the field also. In field we are using HYSD bar and TMT bars currently. So the applications of RC structures. The RC structures we have are we built by structures by using RC, that is reinforced concrete, in residential building, commercial buildings, flyovers, bridges, water tanks, infrastructure buildings, industrial buildings, institutional buildings. All the things are constructed by using RC structures in India. The basic properties of concrete. So we know that the concrete is strong in compression, so it will have high compressive strength, and we know that it is weak in tension, so it will have low tensile strength, and it has good durability, because all the materials which we are using in concrete mostly are inert materials, so which won't react with the environment, so it will have a good lifetime. And the fresh concrete can be molded into any shape, and currently in India it is economical and it is widely used. Grades of concrete, because the concrete have different grades. Each grade is classified based on its load carrying capacity. So generally we are using M20, M25, M30 in building structures, but the grades of concrete is available from M5, M5, M7.5, M10, M15, M20 and M25. Up to 25 it is called as nominal mix, because the mix ratio is already available, and from M30 and above is called as design mix, because based on the properties of materials which we are adding in the concrete, we need to design the mix ratio. For example, if you are considering M20, M represent the mix and 20 represent the compressive strength which it needs to attain at the end of 28 days. Here MPa is also it can be represented as Newton per mm square. Stress strain curve. So if you see in this stress strain curve, this is the stress strain curve for concrete. In this, if you see, up to a certain point we have a linearly varying curve. Beyond that it will become non-linear. So here if you see, the concrete can withstand a maximum strain of 0.0035. So after reaching 0.0035 the structure will fail. So we always need to design in such a way that the concrete is the strain created in concrete is less than 0.0035. So this is the nominal graph for concrete. And the basic properties of steel. We know that the steel is strong in tension and both in compression, so it will have high tensile strength and it will have ductile material. That is, it is a ductile material, because how we are calling it as ductile means you have done the test in materials laboratory. In that, if you see, we will fix the rod, and when we apply a tensile load, it will undergo elongation, then it will form necking, and then it will fail. So that elongation property is nothing but the ductility of the steel, and it will create a good bond because we will provide the twisting on the bar and it will create a outline of outline which will help to create a good bond between the concrete. And commonly available grades are Fe 415, Fe 500 and Fe 550. In olden days we have used Fe 250 also. So this is the stress strain curve of the steel. So if you see here, we have given for mild steel under repeated loading, and it is for a cold formed deformed bars, and it is for TMT bars, and this is the idealized curve for normal reinforcement steel which we are using in concrete. So here if you see, we will have up to a certain point we will have a linear region. Beyond that it will undergo yield point, and after that it will enter the plastic region. So this is the ideal curve which we are currently following for the design purpose. So why we are using concrete and steel together in the reinforced concrete? The reason is, we know that the concrete is strong in compression and weak in tension. To satisfy that or to overcome that, we are using steel, because steel is strong in tension and it is a ductile material. Since concrete is a brittle material which will fail suddenly, so while we are adding steel, it will give warning by undergoing deflection, and that is elongation. So together they form a good efficient structural material. And we know that the concrete supports steel and steel also supports the concrete. The concrete, how a concrete can support steel? It will protect the steel from corrosion and fire because the steel is embedded inside the concrete. And how a steel will help the concrete? Because while as I already mentioned, the concrete will undergo a brittle failure, but steel will provide elongation to the failure material, because which will provide a time to evacuate that particular building. So this is the stress block diagram. Here the first one is nothing but a rectangular section, and second one B is the strain diagram, and third one is the stress diagram. Here if you see, this top portion is nothing but the concrete zone which will carry or which will support the compressive load induced in the structure, and the bottom, these three rods, is nothing but the tensile reinforcement which will support the tensile load. Here if you see, we have provided only the arrow mark because this particular reinforcement area only is going to carry the tensile load, but this entire block will carry, here if you see this entire block will carry the tensile load, compressive load. So this is the stress block diagram, and the remaining portions we will see in the next class. Thank you.